Okay, so here's our third stoichiometry video. This is going to be the one on thermochemical stoichiometry. And I forgot to say in the other two videos that remember, if you're following along and you can always pause the video and work it out first, right? And then see, and then push play and then see if you're getting the same answers I'm getting, right? And getting the same work that I'm getting. Okay, so we have a thermochemical equation here. And we can also notice what type of a reaction it is, right? If it's exothermic or endothermic, remember that? So remember the sign here is negative, so it's telling us that it's what? It's exothermic, right? This is an exothermic reaction. And so we're gonna look at our thermochemical equation, right? And here's our question: how many kilojoules are produced when 455 grams of carbon dioxide are also produced? Right? So in this case, we're given 455 grams of carbon dioxide and we want kilojoules. Right? So instead of like with the other two stoichiometry ones that we were doing, we were looking at two compounds, right, that were in the balanced equation. But this time we're looking at carbon dioxide and kilojoules. So that's why we're going to need what we call an energy to mole ratio instead of a mole to mole ratio. Right? So in this case, we're going from grams of CO2 to moles of CO2, right? Our usual grams to mole conversion, and then moles of CO2 to kilojoules. So instead of 3 steps, we're only going to need 2 steps here. All right, so our per expressions here, all right, will be the grams of carbon dioxide to moles of carbon dioxide. So we need our molar mass of carbon dioxide. So that's 44.01 grams of carbon dioxide per mole. And then for us to go from moles of carbon dioxide to kilojoules, we're going to need what we call our energy to mole ratio. The energy in this case is 2044 kilojoules. Energy to mole. And so we only care about carbon dioxide here, so that's the only coefficient we worry about. All right, so 2044 kilojoules for every 3 moles of carbon dioxide. All right, so those are only per expressions we're going to need. So let's go ahead and start with our given, 455 grams of carbon dioxide. Convert it from grams to moles using molar mass. 1 mole of carbon dioxide per 44.0 grams of carbon dioxide. Grams of carbon dioxide cancel. Times, now the energy to mole ratio with energy up top, because that's what we're solving for. Kilojoules up top for every mole of CO2, so moles of CO2 cancel. And we get 7.04 times 10 to the third kilojoules, right? And then we can also say whether it's absorbed or evolved, right? And in this case, the negative sign means it was evolved. If it was positive, then it would be absorbed. Okay. All right, so that's going from grams to kilojoules. But what if we have a problem where it's asking us to go from kilojoules to grams, right? So then, all right, if we're looking at the same equation here, right, let's put it this way, like this. Okay. So still looking at the same equation, right? But this time, right, we're talking about propane, right? So it says how many grams of propane will be needed to produce 1.75 times 10 to the third kilojoules of heat. So now our given is the kilojoules. 1.75 times 10 to the third kilojoules is given, and we want grams of propane. So this time we're going from kilojoules to grams, but you still have to go to moles first. You always have to, moles is always that middle part that you have to go to, right? Because you have a mole to mole ratio, an energy to mole ratio, so moles has to be there. So kilojoules to moles first, moles of propane, and then moles of propane to grams of propane. Okay. So our per expressions here, right, would be our energy. So from kilojoules to moles, our energy to mole ratio, 20, right, the 2044 kilojoules, right? So we're looking at energy to propane this time, right? So 2044 kilojoules, right, for every, and there's a 1 there, right? So 1 mole of propane. All right, so this time it was a 1, last time it was a 3, because it all just depends on what the coefficient is, right, for the substance you're looking at. And then the molar mass of propane, right. Molar mass of propane, 44.10. Right. Oh, pretty close to carbon dioxide there. 44.10 grams of propane per mole of propane. Okay, so go ahead and work it out here. Start with our given, 1.75 times 10 to the third kilojoules times our energy to mole ratio. This time the moles goes up top so that kilojoules can cancel. 2044 kilojoules on the bottom. Kilojoules cancel. Times the molar mass, 44.10 grams of propane per mole of propane. Moles of propane cancel. And we get 37.8 grams of propane. So if we are burning and we're getting this much heat out, it's going to take 37.8 grams of propane to do so. Okay? All right? And so there you have the thermochemical stoichiometry problem. All right? So again, don't forget that if when you're working these problems, you're having any issues while you're studying, send me an email or come see me in office hours. Okay, take care.